Okay, welcome to chapter 12, part 2. How is food produced? Let's see what we've got here. So we've got croplands, we've got rangelands and pastures, and we've got oceans, fisheries, and aquaculture. And we talk about each one of these throughout the course. But some quick little fun facts here. Croplands. Of these, croplands are mostly efficient. That's the word I'm looking for. So on croplands produce 77% of the world's food, and they do it on 11% of the world's land. Pretty nice. Rangelands, which the end product is not grain for us to eat, it is meat. On these rangelands and pasture lands, 16% of the world's food is produced on 29% of the world's land. A lot less efficient. And lastly, ocean fisheries and aquaculture only produces 7% of the world's food, which is crazy because we have, the ocean is huge and we think that we can't destroy it. Right, it will always be there, but as we'll see later on, we are destroying it at an alarming rate, especially the food and the quantity of food in the ocean. Terrible, terrible, terrible. Let's move on. Agriculture, high input monoculture. So first off, if someone says the word monoculture or says the word high input agriculture, they're kind of synonymous. They mean the same thing. Okay, a monoculture, mono meaning one, is large fields of one type of thing, and that's how we do industrial agriculture in the United States. We grow huge, vast fields of corn, or maybe wheat, or maybe some barley, but we do one crop as far as the eye can see in perfectly straight rows. High input, it's called because it requires lots of inputs, right? So we need to add fertilizers to keep this going, pesticides, herbicides. We use tractors, which have high quantities of gasoline going into them, so petroleum products, high quantities of water to irrigate these things, so it's high input. We produce single crops with the goal to always, always, always increase yield. When we get to the Green Revolution, we'll talk a little bit more about that. Plantation agriculture is a type of monoculture that we see in developing countries, which is hopefully that term plantation will make you think of a developing country and you'll associate it with that. So these are cash crops that are grown predominantly for the first world. So in these plantations, the people who grow them usually never consume them, right? A lot of the places in the world where they grow chocolate, those people think that we make wine out of the beans that get turned into the cocoa beans. They have no idea what we do with it. We have no idea that we make a sweet, delicious tasting candy out of it. So coffee, sugar cane, bananas, palm oils, and greenhouses. We do have areas where we've got very, very large greenhouses where we can mass produce food at quite an alarming rate, which is kind of crazy. In greenhouses, they do also take up land, but generally speaking, we can grow a larger variety of crops and a higher number of crops on a smaller land because we can stack crops vertically, in which you cannot do in fields, so it increases our input or our yield. So traditional agriculture, low input, we're not putting a lot of things into it. So traditional subsistence farming was growing enough food just to supply your family with what they need day to day to survive. Traditional intensive, right, you've increased that a little bit. Now you're supplying all of your family with everything they need, plus a little bit extra that you can take to a market and you can sell. And we see that a lot in third world countries. A lot of people are traditional intensive farmers. Polyculture, growing different plants, maturing at different times, and they're planted together. It's the best low input method, and we'll talk about that in a second when I talk about the Native Americans and their planting style. And then slash and burn, when it was done on a small scale, when we didn't have 7.3 billion people on the planet, it was okay. You could take an area of forest, you could cut down the trees, burn them, right, to put the nutrients into the soil, grow crops in them for 3 to 5 years, and then walk away after the soil is no longer fertile. You let it lie fallow, leave it for 30 years. Trees grow back on it, diversity returns to it, and in that time frame, you've moved on and gone to a different part of the forest. But again, large scale, with a lot of people to grow food for, you can't clear all of the world's forests and burn them and turn into farmland, which is what we are indeed trying to do. But once we lose all that diversity, and we lose the trees that sequester carbon dioxide, and we lose the trees that also pump oxygen into the atmosphere, which we need to survive. Alright, so I guess I'll go to here. So the Native Americans, they had a farming style that they called the Three Sisters. And they called it that because they were growing three things. They were growing corn, they were growing squash, and they were growing a legume, which is a bean of some sort. It could be soybeans, it could be green beans, it could be peanuts. Peanuts are not a nut, they're actually a bean. So what they would do is they do mature at different times. The first things they would plant would be the corn. And the corn would grow into this nice stalk. And on that they would plant on the base the legumes. The legumes then need their vining, so they need something to grow up and around, which they grew on the corn stalk. And they would plant squash, and the squash acted as a ground cover and reduced erosion in times of wind and rain. Now, when the British showed up, they looked at this and said, "What the hell are these people doing? No wonder why they're savages. They don't know how to farm. There's no straight lines. There's no rows." They didn't realize that the polyculture method used by the Native Americans was one of the best methods ever. And it just so happened that if you eat corn, squash, and legumes together, right, in one sitting, there's no meat being consumed there, but there's enough amino acids in all three of those things that when combined, your body has every amino acid needed to make every single type of protein that your body needs. So the three of them together constitute a complete protein. Now, the Native Americans didn't know that was going on, but they just knew that the soil did well when the three crops were grown together, and their bodies felt good and they were healthy when they ate those three crops together. So that's why they grew them that way. Not to mention the fact that legumes, right, they've got a mutualistic relationship with the bacteria that sucks nitrogen out of the air and puts it into the soil, so the soil becomes healthier. So it was a win-win. The Green Revolution started in the 1950s, and the first Green Revolution is what became the high-input monocultures. It was the moving from the small mom-and-pop farms across the U.S. to the big conglomerate corporations that own 30,000 acres of wheat fields in the Midwest United States. And they focused on getting higher yields. In the 1950s, it was common to get 75 to 100 bushels of corn per acre. Today, it is not uncommon to get 350 bushels of corn per 1 acre. Who's there at the door? Can we talk to him for me? Thank you. Because of the high inputs, they can increase the yields off of them. The second Green Revolution took place in the late 60s, and the purpose of the second Green Revolution was to give fast-growing wheat and rice to developing countries who needed something that's going to grow quick, because they don't have time, because they're usually poor, lots of poverty, to wait around for these things to grow and reach maturation date. They need something that's going to grow faster so they can feed their people more readily and keep them alive. So what are genetically modified foods? Food crops created by humans directly manipulating the DNA of an organism. Well, the next couple slides we'll look at some examples. But it's us going in and changing the genome of certain plants. Most often created by combining DNA from multiple organisms into one organism, also called transgenic organisms. So there's a little cartoon over there. Sweet, you guys can pause it and look at it. Okay, so what are some examples? The golden rice I mentioned in 12.1. They took, what was it, 2 pieces of DNA from a daffodil and 1 from a bacterium. They put it into the rice, standard rice, golden rice, and now it makes vitamin A, or the precursor to vitamin A. Tomatoes traditionally don't like to grow when it's cold outside, so they took the gene that allows salmon to survive freezing water conditions and put that into the tomato so we can grow vegetables, tomatoes, longer into the cold season. Right? And this last one, BT corn. If you go to the store and you buy anything that's processed and it uses corn or corn syrup, you're eating BT corn or genetically modified corn. We do not require labeling in the United States, so basically it's safe to assume, because we use so much of it here in the U.S., that all the corn products you consume are genetically modified. Now, this can give you both perspectives. Why are genetically modified foods good? Why are they bad? Traditionally, you have to spray your fields with lots of pesticides to kill bugs. What they did is they found that the bugs, especially the caterpillars that love corn, they get killed by this bacteria called Bacillus thuringiensis. And this BT bacteria is a commonly found bacteria in the soil. So what they did is they found out which gene actually that's located in the bacterium kills the caterpillars that eat it, right? Which one of those genes is actually killing the caterpillar? Once they found that out, they took that gene out of the bacteria DNA and they put it into the corn. So now when these caterpillars land on the corn and start eating any part of the plant, they will indeed die, and we don't have to spray them with so many pesticides. So that seems like a very good thing. And it is, and that can be. But what people are concerned about is, number one, do we have the right to know that they're genetically modified? And I believe that we should have the right. We do have the right, and we should be notified that they're genetically modified. Number two, we could be creating whole new allergies that we don't even know of yet, and putting them into our food and distributing it to all the people. So a lot of people feel like we should do more tests to see what is going on, what's going to happen when we add genes, additional DNA into this food. What are the repercussions of that? You can pause this right here to look at the advantages and disadvantages of GMOs, or genetically modified organisms. I'm going to move on. Industrial meat production produces 50% of the world's meat. These things are called CAFOs, concentrated animal feeding operations. And this is predominantly the way beef and most meat is produced in the United States. So those pictures when you buy food and it has the nice little farm on there with the cows eating the grass, that's all BS. That's not how meat is produced anymore. So let's look at this here. Okay, so North America, Europe, Japan make up 20% of the world's population, but we consume 80% of the world's milk and meat. Thank you, sir. Just put it right there. Appreciate it. Developing countries have 80% of the world's population. We raise 60% of the meat, but consume only 20% of the meat. Right? Most of that is exported. 90% of North American grain is used to feed livestock. What a waste of energy. That's going back to the idea of the trophic pyramids. If we eat lower in the trophic pyramid, we can sustain far more people. The higher we eat on the trophic pyramid, the less people and organisms can be sustained on this planet. All right? So going back to this picture here, the concentrated animal feeding operations, why is this bad? The whole point of eating anything really is because your body needs it, right? So beef traditionally is very high in omega-3 and 6 fatty acids, which are needed by your whole body, but especially your brain, and is used to create the myelin sheaths that surround your neurons. Very important. When we take cows, and we take them, which have evolved to eat grass, and we remove them from the fields, put them into these concentrated animal feeding operations, we don't feed them grass anymore. We feed them corn and soybeans out of a bin. They don't eat corn and soybeans out in nature. So what happens is, since they're not used to eating that, they don't make the same type of meat. So their meat has almost zero omega-3 and 6 fatty acids. So essentially the whole health benefit that you gain from the meat is lost if you eat this type of beef, which is the majority of the beef that's in the United States. Not only that, but you change the bacteria in their gut. So all these E. coli poisonings that you hear of are because in these concentrated animal feeding operations, they're walking around ankle deep in their own fecal matter. It gets caked all over their hide, and the fecal matter contains E. coli, which is a new type of E. coli that has come because the bacteria in the gut has changed, because they're no longer eating what they've evolved to eat, which is grass. They're eating a new food, so the bacteria that breaks it down is different. And that E. coli just happens to be incredibly toxic and poisonous to us as humans, which is not good. Chickens are stacked up in cages so high and transported, and they can't even get up, stand up and move. So by the time they get from the poultry farm to the what am I looking for? The slaughterhouse, the ones on the top have crap and piss, and all the ones on the bottom, and their skin and feathers are completely caked in too. So there are some definite downsides of concentrated animal feeding operations. But if everyone wants to become an affluent country and eat lots of meat, which eating meat is a sign of wealth, that's the way meat is going to be produced. The only way to stop it is for people to consume less meat. So meat versus grain. Every 7 kilograms of grain fed to cows produces 1 kilogram of edible meat. The other 6 grams are used by the animal for energy. They do not become part of the animal. They're lost as heat. Remember, going through our trophic pyramid, 90% is lost as heat throughout the trophic system. If we ate grain directly, we would get 21 times more calories and 8 times more protein than eating the meat that's produced by the grain. Animal feedlots, advantages, disadvantages. Pause it, take a look at them. Fisheries. Okay, so important source of protein in many countries, especially Japan. That's where the majority of their protein comes from. Fisheries provide 57% of the world's seafood. This is actually going out and fishing it. Fishing methods have increased and become so much more advanced over the years that we've gotten really good at taking tons and tons of fish out of the oceans. GPS long lines, which have 60,000 hooks. We just reel them in. We've got thousands and thousands of fish on the line. Trawl nets, we just drag them right here, right? You can see them lifting all this fish out of the ocean. Now, the result of that is that 25% of fisheries are depleted. And when I say fisheries, what that means is you take tuna. It's considered the tuna fishery. Salmon is the salmon fishery. So 25% of fisheries are depleted, meaning that that fish is so low, the population in the environment, we can't even find them to harvest them anymore. 77% are exploited, meaning they're on the verge of being depleted. And tuna is one of those, especially yellowfin and bluefin tuna. Aquaculture is, they're calling it the blue revolution. Now there could be some benefits in here, but in the short term right now we're finding a lot of problems. So right now 43% of the world's seafood is provided in aquaculture. The majority of it is done in China, and they do it in rice paddies. So they take the fish, throw them in the rice paddies, and then they induce eutrophication. Right? They want the algae to bloom in those rice paddies because the fish eat the the algae in the rice paddies, and that's what they grow. They also, in addition to that, provide grain and corn to the fish. Your farm-raised tilapia is fed almost exclusively corn. The problem is, when the hell did you ever see a wheat or cornfield in the ocean? Never. These fish don't eat grain and corn. So again, that whole problem we had with the beef, not generating the omega-3 and 6 fatty acids that they should, same thing with fish. That's why fish is considered a brain food, because of the omega-3 and 6 fatty acids. You stop feeding them what they're supposed to eat, what they've evolved to eat, they're not going to produce the fatty acids that are beneficial to us. So the whole point of eating the tilapia becomes mute, right? You lose that quality of the fish. It's hard to see right here. This is one of the things they're going to do in the future. It's like this ball that they'll keep the fish in, and it's attached to some chains. They can actually move it around the ocean, so you get different currents moving through there, providing different types of food to the fish. And one of the problems with aquaculture is that it's done on the coastline of all these countries, and so they're putting so many fish into a small area, and then you cause eutrophication in some areas, and then you're not moving the fish ever, so they're just pooping and crapping, and it just makes the whole coastline so dirty and full of bacteria that you can't do anything with that coastline afterwards. Right? You remove the fish, and it's just inundated with all this bacteria. It's very toxic to anybody trying to go swimming there. Advantages, disadvantages, pause it, move on. And that's it for 12.2.